Hello, I'm Ryan Baker, and this is Big Day in Education. Welcome to Week 8. In Week 8, we'll be talking about discovery of models. Some folks think that discovery of models seems a little bit tricky. But in fact, discovery of models is so simple that a 6-year-old could explain it. And now, here to do so is today's guest lecturer, Maria Baker.
The big idea of discovery with models is you develop a model of some phenomenon using prediction, clustering, or knowledge engineering. Then you use that model as a component in another analysis.
So we can conduct discovery of models in the case of prediction, where the created model's predictions are used as predictor variables in predicting a new variables. So the predicted variable becomes, in a new analysis, the predictor variable. And that could be classification or regression you could use. You can use discovery of models in relationship mining, where you take the created model's predictions and you study the relationship between those predictions and additional variables. So your predicted variable becomes now part of a relationship analysis. This can enable a researcher to study the relationship between a complex latent construct and a wide variety of observable constructs. And you could use this in correlation mining, association rule mining, sequential pattern mining. What will you? Another area of discovery of models is composing models out of other models, which can itself be kind of using in prediction modeling, but becomes something different. So examples of this abound. There are models of gaming system and help seeking that use Bayesian knowledge tracing models as components. Models of preparation for future learning use models of gaming system as components. Models of affect use models of off-task behavior as components. Models predicting standardized exam scores use models of affect and off-task behavior as components. And models predicting college attendance use models of affect and off-task behavior as components. So it's all like pyramids where we build one model on top of the predecessor models. Kind of like, I think it was Isaac Newton saying about standing on the shoulders of giants, or in this case, standing on the shoulders of giant models. Now when I talk about this, people often worry about building a model on top of imperfect models. And the thought is the error going to pile up? Like I'm going to have some error here, and then I'm going to have even more error here because I'm going to have all the error here plus all the error here, and then I'll have even more error. So by the time I get up here, I just have absolute junk. Well, in fact, this may not be as much of a risk as people worry about. I tend to think it's not. And the reason is because if the final model successfully predicts the final construct, do we care if the model it uses internally is imperfect? Systematic error at each step is going to be taken into account at the next step if we refit at each level. So we've got error here, but when we fit the model here, our model is actually going to take account of the error here in making its prediction. And it's going to find other predictors to kind of deal with that imperfection. So at each level, we're kind of fixing the flaws we bring in from the previous level. That said, there are some validity issues that really need to be taken into account, and more on that in a minute. So discovery of models. Baker and Yosef argued back in 2009 that discovery of models is a key emerging area of educational data mining. And I think that's still true, although I'll admit that it's been a little bit slower to become prominent than I expected way back in the dark days, the ancient days of 2009, 4 years ago. It has emerged a little more slowly than I would have guessed. But that said, there are a lot of discovery of models analyses in the published literature. Here are 7 we've already talked about in class. San Pedro et al. From week 1, Alavin et al. From week 3, Beck et al. From week 4, a couple Baker et al. From week 4, Fanksali et al. From week 5, Baker et al. and Press from week 6, and Gauda et al. From week 6. So that's some examples that we've already talked about. In the next lecture, I'll go into a little more depth on another analysis that is discovery of models, which is work to use social network metrics to assess the effectiveness of admissions practices. So discovery with models has several virtues, several advantages. First and foremost, it becomes possible to analyze phenomena at scale. Oftentimes there are phenomena that we don't really have the ability to get training data for at large scale. So we get training data for a small subset of data, and then we build a model, validate the model, and then we can use it at a broader scale. And this is true even for constructs that are latent. So in other words, it's hard to detect them automatically. Constructs that are expensive to label by hand. This is really where this approach shines. And at scales that are infeasible, even for constructs that are quick and easy to label by hand. Take gaming a system. We can label gaming the system in text replays in 8 to 40 seconds. But if you want to observe gaming a system in every single student in the country in a system used by 50,000 students for an entire year, it doesn't matter how much mechanical turk you throw at it, you can't do that. With Discovery with Models, you can. Discovery with Models scales easily from hundreds to millions or quadrillions of students. We don't yet have quadrillions of students, but we'll get there. Entire years or eventually even entire lifetimes. For example, maybe we'll be able to predict Nobel Prize winners from kindergarten drawings. I'd like to show a picture of a future Nobel Prize winner that I happen to know. Another advantage of Discovery with Models: it supports inspecting and reconsidering your coding later. It leaves clear data trails. You do DWM, and you can look and see the model, and you can see whether you trust the model, and maybe you want to take it out in some places and use a different model, or maybe you want to say, here's where I trust it and don't. And you can substitute an imperfect model with a better model later and rerun. You can't do that with hand coding. You really can't do it with field coding, and even with video coding, it's real time consuming. With Discovery with Models, it's really easy to swap in and out different models. This promotes replicability, discussion, debate, and scientific progress. Now, for all the advantages of Discovery with Models, and I think they're huge, there's one big disadvantage. It's really easy to do something badly wrong for some types of Discovery with Models analyses, and there's no warnings when you do. So think validity. Validity is always important for model creation, and it's doubly important for Discovery with Models. Discovery with Models almost always involves applying the model to new data. And how confident are you that your model will apply to the new data? There are many challenges to valid application of a model within a Discovery with Models analysis. For example, is the model valid for the population? Is the model valid for all the tutor lessons or other differences or curricular aggregations? Is your model valid for the setting of use? What if you build your model with classroom data and then you apply it to homework data? Are the behaviors you're looking at going to look the same? Is the model even valid in the first place? And that's especially important for knowledge engineered models. Recall my discussion of when knowledge engineering can be a dangerous practice, though it is in some cases a really great practice. So in the next lecture, I'll discuss a case study that I mentioned a little earlier for Discovery of Models. Thank you very much. I'm Ryan Baker. This is Big Day in Education.